Recording, share screen, and here we go. We've got a calculator. We have paper. The first thing we're going to talk about is finding the domain of radical expressions, that is square roots. So let's say you have y equals the square root of x. Okay, well, the graph kind of sorta looks like this without the wiggly x and y axis. Kind of looks like that, where it curves up slowly, much more slowly than the way I drew it, but that's the general shape anyway. The domain, you can tell, goes from x equals 0 to the right forever. So the domain in interval notation is bracket 0 to infinity. The whole right side, well, actually, the whole first quadrant, right? That's what they call this. They call it Q1, the whole first quadrant. And in set builder notation, it would be all x such that x is equal to or greater than 1. 0. Ha! Equal to or greater than 0. Okay? Everything is based on that. All right? Because once we get to more difficult square roots, like, for instance, how on earth do you find the domain of that? Well, if you try to graph it, you can graph it okay. Let's do that. The square root of 3x plus 2. So second x squared, and underneath is 3x plus 2. And then all of that's under the square root. I have to jump to the outside. And now I'm going to graph it. There it is. So it goes from not -1, but some fraction, negative fraction, between 0 and -1. And just by looking at it, I don't have any idea what that is. So there has to be a better way than just looking at a graphing calculator screen or a graph in general. And here it is. You take out what's called the argument of the function, and that's what this is. With a square root, anything under the square root sign is called the argument of the function. Take out the argument of the function, 3x plus 2, and set it greater than or equal to 0. And then solve for x. So I will subtract 2 from both sides. 2 minus 2 is 0, so I'm left with 3x is greater than or equal to -2. And then I divide by 3 and I divide by 3. The 3's cancel, and I've got x is greater than or equal to -2/3. thirds. Ah, now it makes sense. This right there on the x-axis, the place on the x-axis where the graph starts is negative 2/3. But I wouldn't have known that just by looking at it. So this is a system that really helps us. And what you have to memorize is that whatever goes under the square root radical, you have to set greater than or equal to 0, and then solve for x. So for instance, if we had g of x equals 5 minus 4x. Well, I don't know. Let's look. 5 minus 4x is greater than or equal to 0. So now this is an inequality, okay? I need to keep the x on the left because it makes graph inequality much, much easier. So instead, I'm going to subtract 5 from both sides. Five minus 5 is 0. I'll be left with 0 minus 4x is greater than or equal to negative 5. So negative 4x is greater than or equal to negative 5. So I divide by negative 4, and I divide by negative 4, and if that isn't enough, whenever I divide by a negative number, I need to not only cancel that out, but turn my sign around. So x is less than or equal to, or is to the left of, positive 5/4. Let's see what that looks like. I am going to clear that, and then I'm going to say second x squared, and that gives me the square root sign, 5 minus 4x, and then jump to the outside. Okay, I'm going to graph that. Doggone, it's true. 5/4 is 1 1/4, 1 1/4. So that looks like it could definitely be 1 1/4. And then look, the graph goes off to the left. So we're talking about the part of the x-axis that goes to the left of 5/4. So this is going to be my domain. And let's look at how we should write the domain. It depends on the instructions. If the instructions say set builder notation, I'll just call it SB, then we would have all x such that x is greater than or equal to negative 2/3. That means x is to the right of or equal to negative 2/3. Now, why it's important to know to the right of is that if they ask for interval notation, then I'm going to have, okay, to the right of negative 2/3 to infinity. These are the same thing, but done with, these are the same quantity being described, but they're done with different methods. This is the set builder notation. This is the interval notation. Now over here, if we write this in set builder, set B, let's call it that, that's better, set. Okay. Then we'll have all x such that x is less than or equal to 5/4. And interval notation. No, that's not interval notation. This is interval notation. If we're talking about x can be any number to the left of positive 5/4, then it's going to go from negative infinity up to negative 5/4, and then it positive 5/4, and it's allowed to actually equal positive 5/4. So there you go. That's how you find the domain of what are called radical expressions. Because this sign right here that looks like a square root is actually a radical. That's what that sign is called. Now, if you're taking a square root, there actually is an invisible number there that you don't often see unless you're having to work with it. And that's a 2. It's the only instance of an invisible 2 that there might be more, but I don't know what it is. This little number out here, oh dear, this little number out here, it'll come to me. I forget what it's called. This is the radicand under here. You don't have to know that. But anyway, there's a 2 there. Now, for a cube root, for instance, the cube root of 8 is 2, because 2 times 2 times 2, that is 2 to the 3rd power, same as that, equals 8. So there is a cube root, and then there's a 4th root of something, like the 4th root of 16 is 2. I was forced to memorize all these 2's. The 5th root of 32 is 2. Isn't this fun? The 6th root of 64 is 2. And the 7th root of 128 is 2. And after that, I don't know them. Just the way it is. I just don't. 216? I'm guessing. No, it's not. Never mind. Okay, so there are all different kinds of radicals, okay? This also is what we're talking about. And there's a shorthand system. For instance, suppose you have the square root of 5. That's not a perfect square. Remembering that you have an invisible 2 here, or the 3rd root of 7, that's not a perfect cube root, or the 4th root of 9. I don't want easy answers here. There's another way that you can write this. And it's all dependent on what the power is in there. So 5 is just 5 to the 1, and 7 is just 7 to the 1, and 9 is just 9 to the 1. So another way to write this is 5 to the 1/2 power, and 7 to the 1/3 power, and 9 to the 1/4 power. And in fact, let's come up with it. How about 17? I'm trying to think in terms of primes. How about the 5th root of 17? 17 cubed. There's a shorthand way of writing that as well. 17 to the 3/5. The power goes there, and the word I keep forgetting goes here. Darn, that's going to bother me. I'll remember right after class is over. You know how that is. You go wash dishes and you suddenly remember how to do the math problem you got wrong on the test. That always was true with me. I had to wash dishes before my mother got home from work. So I'd get off school after having a demon of a math test, and I'd walk home and I'd start washing dishes, and it never failed that when I was washing dishes, it suddenly would appear in my brain how I should have worked that problem. It's so frustrating. Anyway, this is a rule that you did not learn, so let's go over all of our rules of exponents. Let's just take x. Let's let x be our base. If I have x to the 3rd power times x to the 4th power, if I'm multiplying these, as long as the bases are exactly the same, the answer I get will be the answer I would get if I added the 2 powers together. But for this, the 2 bases, the numbers at the bottom, have to be the same. So for instance, 3 to the 2 times 3 to the 5 equals 3 to the 2 plus 5, which is 3 to the 7th power. That's one of the rules. Now there's another rule. Let's use 3. Let's stay with 3. We could have 3 to the 7th power over 3 to the 4th power. The bases are the same, so we subtract the exponents. 3 to the 7 minus 4, which is 3 to the 3rd power, which incidentally is 27. That's another rule. All right, this is the multiplication rule when the bases are the same. This is the division rule when the bases are the same. And then, if you have any base, you name it, any base, like 2 to the 5th power, and then you raise it to another power, like the 3rd power, what you do then is you multiply the powers. So you'll have 2 to the 15th power, which I believe is a really big number, and I don't even want to think about it. Well, you learned these before. You learned those in beginning algebra. Now, there's one that you did not learn, that you learned in intermediate algebra, which is what you're taking right now. So here's the fourth rule. You could call this what? The first rule, and the second rule, and the third rule. Oh, and another one you already learned, the fourth rule, and that is that any number, how about 12? I can make it like 12,532. Doesn't really matter. Any number raised to the 0 power is 1. That's another rule. But now, the one that you didn't learn before that you are going to learn now, here's the formula for it. The nth power of b, that is the nth root, I'm sorry, the nth root of b to the mth power equals b for base, the base raised to the m over n power. And now you know all the rules of exponents, and you're going to actually be living in exponent land when we talk about logarithms at the very end of the semester. So we have these rules. These are all called, no, they're not. These are called these up here along with this. These are called rational exponents. R-A-T-I-O-N-A-L, exponents. Rational, remember in math, rational, the word rational means of or pertaining to fractions. And these are indeed fractions. Okay, but they are exponents and they are real. So some of your homework how about, I'm debating. The cube root of x to the 5th power times the square root of x to the 7th power. Now index, there you go, I knew it would come. There's an invisible index. These little numbers at the end of the slanted line on the radical sign are called indices, that's the plural, but one index. So, yes, this is an index, this is an index. This is an index, this is an index, this is an index, this is an index, this is an index. So this is an index and this is a power. And what the rule says is that this can also be written in a different system. And don't you know it? Don't you know it? We give everything in math names. Okay. This, the nth root of b to the mth power. This is called radical notation because you're using a radical sign. Radical notation. And this, b to the m over n, is called exponential notation. Notation just means a way of writing. So anytime you have a root of any kind, a radical of any kind, it can be expressed in radical notation, or it can be expressed in exponential notation. Now, there is definitely a value to exponential notation. I don't know who discovered this, but it was a pretty good discovery, because watch this. Here we have, let me take that circle away. Okay. We have the cube root of x to the 5th times the square root of x to the 7th. You cannot multiply radicals that have different indices. So it's hopeless. No, it's not. It would be hopeless. It would be hopeless if we didn't have exponential notation and with a rational exponent. Rational, there's the I right there. Rational exponent. Because we can do it if we change both of these to exponential notation. The bases are the same. So I can use the rules of exponents. Now, there are various quickie rules. Oh, yeah, okay. Well, wait a minute, as long as I'm here. There you guys are. Okay. Yes. There are all sorts of quickie methods for doing that quickly. On the other hand, your calculator will also do it for you. Of course, you can, if you know how to do it, you can always do it by hand, but a lot of people just don't know anymore. So we're going to make the calculator do our work for us. And I'm going to add 5/3 plus 7/2, 7 halves. I'm going to add these on the calculator. Yeah, that'll be very visible, I think. Okay, so 5 divided by 3 plus 7 divided by 2. Fractions are just division. Okay, now, instead of hitting enter, because I would get this ugly answer, bleh. No, we're not going to do it that way. We are going to math frac this. So I hit enter to accept frac. And then I frac it again because it's telling me, do you want it in its own little calculator language? It's saying, is this what you want? Do you want me to frac that answer? And yes, I do. So I hit enter. I need to go get a drink of water. There's your answer. What was it? 31 over 6?
Yes.
Thank you. We're not done because you have to read the instructions with the problem. But often, even most of the time, when you start out with radicals, it's going to tell you to give your answer with a radical. If you start out with fractions, fraction exponents, then you're going to be expected to leave your answer in fraction exponent form. But we didn't, we started out with radicals. So let's assume that we are supposed to change this back to radical form. I can do that. This is the index that goes in this position right at the very tip of the diagonal line. Okay, so here's my radical. Now, 6 is going to go here. And x to the 31 is going to go here. But sometimes the problem is easier, and you'll see some of those problems tomorrow. Yeah, tomorrow. Do it like this. So the 31 can move out here, and what you do is you take the 6th root first, and then you raise it to the 31 power. The way it's written down here, you would raise whatever x is. You would raise it to the 31 power, and then you would take the 6th root. So, yep, we could not have multiplied these if it were not for these. And this rule right here. Of course, there have only been graphing calculators around for a few years now. Few years, 1980s. Some of you weren't even born in 1980s. The 1980s. But it's really not as long ago as 500 years. Okay, so let's see what we've talked about so far. We talked about finding the domain of radical expressions. We talked about radicals. We talked about indices and different kinds of indices and how there are really an infinite number of roots that you can take. And we talked about fraction powers, which are called rational exponents, if you want to be very respectable. And we talked about, briefly reviewed the rules of exponents and then added this to the rules of exponents. And then talked about this. Okay. this was what you have to do, and you'll get to do it more. This is what you have to do if you try multiplying radicals that have different indexes, different indices. What happens if they're both square roots? Like the square root of 5 times the square root of 7. They're both square roots. That is so handy. Watch this. Square root of 5 times 7, which is the square root of 35. What if I had the cube root of 5? How about that? The cube root of 5 times the cube root of 7. Same thing applies. As long as the index is the same, all you have to do is make one big index and multiply those two numbers that are called radicands underneath. So you see, that's easy as long as the indexes are the same, the indices. It's when the indices are different that it can be a pain. But thank goodness with most graphing calculators and scientific calculators, it's very, very easy to add fractions and subtract fractions and multiply fractions and divide fractions and get a fraction answer, which is what MyMathLab asks for most of the time, but not all the time, so don't be fooled. Okay, let's see what other good things are waiting for you. What is that? Okay, now let's make this bigger. There. Anyway, it says rewrite without rational exponents and simplify if possible. Simplify in this context means find the answer. All right, so what they're giving us here in problem number 1 is they're giving us this, x to the 1/6 power, and they say change it, get rid of that rational exponent, and simplify if you can. We don't know what x is, so we can't simplify it, but we can write this without a rational exponent simply by changing it to radical notation. The 6th root of x, because x to the 1 is just x. That would be your answer to that first problem. No. Bigger. Okay, next one. Now, ooh. Eight to the 1/3. That's a number. That means we know what it is. This is 8 to the 1/3 power, which is the cube root of 8, which is 2. You should memorize that because it happens a lot. But most of you probably don't know that, so let's use the calculator with rational notation and with radical notation to find the answer. Here we go. Now, you see that this is called the caret key, C-A-R-E-T, just like a carat of a diamond. okay? Not a carrot that you eat. Bugs Bunny does not live here. That's going to give you an exponent. So if I type 8 as my base and then hit the caret key, what that does for me is it gives me a little box up here in which I type 3. And then I hit the right arrow key to come down. No, it doesn't. I lied to you. That's a terrible thing to do because 3 is not the exponent. I just deleted. 1/3 is. So I'm going to 1 divided by 3. And then I'm going to come down. 8 to the 1/3 power. I'll show you in just a minute how to do that with the old-fashioned form. Okay, enter. The answer is 2. And now let's go ahead and I'll show you where to find the cube root. If you click on Math, the cube root is right there at number 4. So if you click on Math and then 4, you will get the cube root. And then I'm going to type 8 in there and then hit the right arrow key and hit enter, and we get the answer 2. So you can use rational exponents and you can use radical notation, exponential notation to find the answer when it's nice and exact. I think, though it can give me a headache, I want to, what do I want to do? I want to stop using the new system and use the old one. Let's see. I just went to format and that wasn't what I want. So I'm mode classic. I'm going to change to classic. So I go up. See, I'm using Math Print and that's the new operating system. If I go to classic, that's the old operating system. So I hit enter. I click on enter. And now I go second quit. Now, watch what happens. I'm going to say 8 caret 1/3. See? 1/3 is one number. Excuse me, I'm going to go get a glass of water in a minute. You're going to need to put parentheses around the 1/3. Here are the parentheses right here above the 8 and the 9 key. So left parenthesis, 1 divided by 3, right parenthesis. Enter. There you go. Same exact thing. I'll be right back. And blow my nose. How about that? Let's do it again. Let's see what the next problem is. Incidentally, finding the answer 2 is what simplified. One of the meanings of simplify when you're dealing with radicals. Now, the next one is all letters. But now, number 4. Is 16 to the 4/3 power. Well, that can also be written as the cube root of 16. No, it isn't. It's the other way around. It's 3/4 power. So this can be written as radical index is 4, 16 is 3, so I would have to find 16 to the 3rd power, a huge number, and then take the 4th root, or, trust me, it's much easier to take the 4th root of 16, and then once you got that answer, the 3rd power. How do I know? Because I've taught math for a long time. There. Okay, the 4th root of 16 is 2. 2 to the 3rd power is 8. The answer is going to be 8. I betcha. But let's use the calculator. And I don't know how many people have the new operating system and how many people have the old one, but I'm going to do this next problem with the older operating system, or let's just say old. So 16 to the 3/4. So 16 caret parenthesis 3 divided by 4 parentheses closed. That's to keep the 3 and the 4 grouped together. There's enter. And then I hit enter. And I get 8. And then, how do I do the 4th root? That's hard. Okay, so here I go. Oh, it's especially hard with this. Let's see if I can do it. The 4th root. I would have to say 4 and then push the math button. And I would have to go to the xth root now. So I would have to hit 5. Now with the old operating system, this is what I see. I have to take on faith that 4 is up there in that little place. And then 16. But that feels really bad. So I'm going to go back and see just because it feels better. And then, am I going to raise that to the 3rd power? I don't know. Let me see. This is an exciting adventure. Usually I do problems like that in 2 steps. What do you know? Yeah. With the old operating system, that's how you would do it. With the new operating system, I am going to go up, hit enter, and then do the same problem again. 16 raised to the 3 divided by 4, or if you know that 3/4 is 0.75, you could do that. 16 to the 3/4 power, enter. That's 8. Now, the 4th root, I still have to hit 4 first, but then watch what happens when I go to math. 5. Cool! The 4 automatically jumps up into the index position. Okay, and then 16 caret 3. And I hit the right arrow key to come down, and then the right arrow key to go to the outside of the radical, and then I hit enter. So it takes a little practice either way, but it's definitely easier if you can get your hands on the new operating system. If you bought a new TI and you have the wire that goes between your, the connector that goes between your computer and the calculator, you can actually download the new system. So that's enough for my advice. Let's go on. All right. Now, 16 to the negative 1/4 power. What on earth is that? Because I sort of avoided talking about it. 16 to the negative 1/4 power. Now, if you do this by hand, so I need paper. Okay. Number 5. 16 to the negative 1/4 power. Negative signs on exponents are indicators of location, where where the base belongs. 16 to the negative 1/4 power is 1/16 to the positive 1/4 power. It's a convenient way to think of this is negative sign on the exponent is telling us that 16 is in the wrong place. 16 right now thinks it's in the numerator and it's very unhappy. It wants to be down here. Okay, now that we've got 16 to the 1/4 power down there, I know that my answer is going to go down there. So I'll get the calculator and say 16 caret 1 divided by 4. Enter, and that's 2. So that's 16 to the 1/4 power is 2, and the 2 is down there, so you've got 1/2. But if, oh, and I didn't change it to radical notation, which I think is what they wanted, that would have been 1 over the 4th root of 16. But anyway, thank goodness for updates. If I want to do this on the calculator, I can do it in one step. Clear. So 16 raised to the negative 1 divided by 4 power. Come down, hit enter. 0.5, that's 1/2. But feel free to math, frac, enter, and you get 1/2, which is the correct answer. Okay, that's right. Ah, 1,000. The cube root of 1,000 to the negative fourth. Well, of course you can do this just straight off with your calculator, but since you might end up with an X someday, let's do it the right way.
Miss Barbara, I had a question.
Yeah.
For the problem we just did, didn't the first one equal 2?
It's 2 under here. Yeah, so it's 1/2.
Gotcha. Thank you.
You're welcome. 1,000 to the negative 4/3 power is going to be 1 over 1,000 to the positive 4/3 power. It's going to be 1 over the cube root of 1,000 to the 4th power, but I already know what the cube root of 1,000 is. 10. So I know that then I'll only have to raise 10 to the 4th power. 10,000? Yeah. But anyway, okay, this is what's wanted, actually, for you to go to these steps and then calculate this. Okay, so you would say the cube root of 1,000 in your calculator. The cube root of 1,000. So math, cube root is 4. 1,000. 1,000. Come to the outside. I really think it's safer to say enter and then take 10 and raise it to the 4th power. Okay, so that is 10,000. But let us use the calculator because part of today is devoted to learning how to use your calculator. So we're just going to do 1,000 raised to the negative 4/3 power. Clear. 1,000. 1,000 raised to negative 4 divided by 3. Come down. Enter. Scientific notation. Okay. What that says, let's have a quick lesson in scientific notation. Paper. Yes. Scientific notation. And what this says is 1e negative 4. 1 capital E negative 4. This is another math code. The E stands for times 10, and the number that comes after it, the 1 is here. E is times 10, and the number that comes after is the exponent. This is a code, and what it means is you start with 1, with an understood decimal right there, and you're going to shift the decimal 4 places to the left. So 1, 2, 3, 4. And put a 0 in each of those little valleys. So that answer is 0.0001. What if I wanted to, did I math frac that? I don't recall. I don't think I did. I panicked too soon. Let me see if I can math frac that before, I don't know, before I do something else. Math frac enter. No, it's not going to cooperate. And in format, okay, in mode, we do not have scientific notation. It's just doing it. That's one of the things about the TI that I don't like. There is no reason for it to shove you up into scientific notation. No reason at all. It's not that small a number. However, what was the answer I came up with? That. Okay, this is 1/10,000. Right, we found that out when we did the calculator, that the cube root of 1,000 is 10, 10 raised to the fourth power is 10,000, so what you have is 1/10,000. Put that in the calculator. I am truly annoyed. Put that in the calculator. Okay, clear. 1 divided by 10,000. Enter. And there you go. So that is the answer, but not the answer they're looking for, and you can't even math frac it, which means you're going to have to do it the old-fashioned way. So let's do it the old-fashioned way, step by step. 1,000 to the negative 4/3 power equals 1/1000 to the positive 4/3 power, which is 1/the cube root of 1,000 raised to the fourth power, which is, we just found, 1/10,000. And let's see what they want, how they want you to answer, because they do tell you. 1/10,000, A. I'm gonna hit A and see what they do. That's what they're looking for. But nowhere do they tell you what they want the answer to be, do they? Except this, well, that would be true, but it wouldn't be simplified. Okay. Now, letters are back. You can't put letters in a calculator, unfortunately. This is 9x to the 1/8 power. 9 times x to the 1/8, negative 1/8 power. This is not the same as okay, this is 9 times this. So the 9 is going to be left up in the numerator, while x to the negative 1/8 comes down here and becomes x to the positive 1/8. So that's going to be 9 over the 8th root of x to the 1 power, but x to the 1 power is x. This, the answer would be 1 over 9x to the negative 1/8, positive 1/8, which the 8th root, 1 over the 8th root of 9x. See, it's completely different. The parentheses force the 9 to stay with the x, but over here there are no parentheses. The original problem is this, 9x to the negative 1/8. 9 is not grouped with the x, so only the x is being raised to the negative 1/8 power. Okay, we're almost done with the suffering. Let's see what else. Ah! Now here's one that's very interesting. Notice that up till now, all of your negative exponents have been up here. Now we have one down in the denominator. 1 over x to the negative 7/8. That's the original problem right there. And this is going to be, remember that the negative sign says that the base is in the wrong place. That means that x is going to come up here and have a positive 7/8 power. And this isn't empty down here. You always put a 1 in. So this is x to the 7/8 power, which is the 8th root of x to the 7th power. No, I don't want to bother. 9. Ah, now here, we did this before. So we can do this because we did it before. All right. So this is going to be, there's an 8 index. X is the base. You can't use your mouse, you've got to use your arrow keys. And then click on the power. And that's going to be 7. And then I've got to hit my right arrow key to come down and move out. And then I check my answer. Rewrite with positive exponents. Do you see that? My answer is right, but they don't want radical notation. They've decided that they want exponential notation. Idiots. No, I guess I'm the idiot, because I didn't read rewrite with positive exponents. I didn't even read it. Read the instructions. Okay, fine. X moves to the top, so we'll have x raised to 7 divided by 8. There. Nobody told me I had to read the instructions. Well, just because we're about to leave, just so you know, that in the homework, we went from the first homework set to the third homework set, and then the second homework set, and now we're back working on the first homework set. Life can be confusing, but I wanted to make sure we got to everything. All right, so here, notice that the bases are the same, but you might not be able to see it, so I'm going to write it. Small, there. 4 to the 3/5 power times 4 to the 7/10 power. Now this would be easy to do by hand, but let's see what they're asking for before I do anything else. Let's see what they're asking for. Simplify your answer, type exponential notation with positive exponents. In other words, don't solve it. Now, how can you simplify it? Well, never mind. Never mind. I'm not going to say a word. This is going to be 4 with the base written once, raised to the power 3/5 plus 7/10. Now you can math frac that in your calculator. You can go 3/5 plus 7/10 math frac enter. Or you can notice that 5 goes into 10 2 times. So if you were adding 3/5 plus 7/10, all it takes to change 3/5 to tenths is 2 over 2, which is 1. But now I'm going to multiply the numerators together. I'm going to multiply the denominators together. And so this will be 6/10 plus 7/10 should be 13/10. Let's see. So we would have 4 to the 13/10. But let's ask the calculator what it thinks. 3/5 plus 7/10. 3 divided by 5 plus 7 divided by 10. Math, enter, enter. Yes, 13/10. Two minutes. What trouble can I cause in 10 minutes? I mean 2 minutes. All right, really important here. Now what does it say? Simplify your answer. Type exponential notation with rational exponents. Okay. We have. I'm running out of time and I'm panicking. Here we're just, all right, we've got 7 to the 3/6 over 7 to the 1/6. Seven to the 3/6 power over 7 to the 1/6 power equals 7 to the 3/6 minus 1/6. That'll be 7 to the 2/6, which is 7 to the 1/3, which, I was going to write it cube root of 7, but they don't want it that way. They want it left in exponential form with a fraction exponent. So there you go. Goes against my every instinct. Okay, you people have been totally wonderful today, like you always are. And please hang around for questions. But if you don't have any questions, I will see you tomorrow.
Miss Barbara,
Yes.
when is our next exam?
Yes. The last week in October, I think. Let me look to be sure. Get the calendar. All right, next test. Exam 2, 26th, 27th, and 28th
Okay.
of October.
Okay.
The practice exam is up
Mm-hmm.
if you want to see it.
I have a question.
Yes.
I don't know if I'm going to be able to take the test on either of those days. I'm going to be out of the state.
Some people will do anything to get out of a test.
I know.
All the way to Alaska in the wintertime.
No, it's not that. It's just, it's a family thing.
Okay, but see,
Well,
you
I
told
don't
me in
know.
advance.
Mm-hmm. Like a month advance. So,
So remind me before you leave that you told me in advance.
okay, I'm still going to be able to be in the classes. But I feel like it'd just be really hard for me to take the exam somewhere that's not quiet and not at my house.
I agree.
Yeah, so
Of course, I could always say, well, then you've got to take it early.
that's
But
true.
I'm not that much of a jerk.
Okay. I mean, I'll be getting back on the 28th, but late at night because I'm going to Utah. Yeah. So
Utah is so beautiful.
I've heard.
I mean, the country.
Mm-hmm.
I look at pictures of it and it's,
Mm-hmm.
But anyway, I hope you have a good time. I hope it's a good reason and not a funeral or something.
No, it's definitely not. No.
Okay, good.
Yeah.
Then you have my permission. You can, let's see, Wednesday is the 28th. You want to take it on Friday or Saturday? Is that soon enough or you want to take it the following week?
No, that I could take it on Friday. I don't have anything to do on Fridays. So I could take it the 30th.
It's going to be open, okay? So if I accidentally forget and give you a 0, will you please remind me that we talked? And then I'll remember.
Yeah, I'll remind you before I leave too.
Okay, good.
Mm-hmm. Okay. Thank you so much.
You're welcome.
Have a nice day.
You too.
Hey, Miss Barbara.
Hi.
Hello, Miss Barbara. I had a quick question.
Yes.
On the problem we just did of